Hello all. So we'll start now. We'll start with the yesterday's left out part. Hope my screen is visible. Okay, so we need to start off with communication protocols. I'll start with this question again. What is protocol? Communication, we all know communication is transfer of data, but what is protocol? Anyone? Just make it fast because we
rules that forces us to do the thing in a way.
Okay, so basically protocol is a set of rules. Like let's say, for example, I'm from Tamil Nadu. I'm a Tamilian, and most of you are from North India. You speak Hindi, but still we both are communicating through because I use a common language, right? So we need to have a common set of rules, like how this communication to be happen the way. Then only a common, uniform, universal system can be there for communicating between any electronic systems, any electronic components, boards, sensors, anything, right? So we need a set of rules, and that is called protocols, right? So we'll see more about it now. Hope it is getting recorded. Right. So whenever we talk about communication, there will be two things. One is master and another one is slave. Now there can be one master, one slave, one master, multiple slaves, multiple master, one slave, and multiple master, multiple slaves too. Right. So what is master and what is slave? The only difference is master can only control the data flow. Like it can only say what data to flow and how to flow, where the direction of flow. And depending on the protocols, like few protocols have few advantages to master, few protocols have some more restrictions to master, slave, something. So depending on the protocols, the functionality changes. But basically, it is like master decides how the communication should happen. Okay, so communication can be of two types: wired communication and wireless communication. Wireless communication is not in the scope as of now. We're not going to talk about wireless communication. We'll talk about the wired communication. And wired communication can be again serial communication and parallel communication, right? So serial communication is when first I'll talk about parallel communication first. Parallel whenever a data has to be, let's say I have to send hello world. Okay, so this hello world will be converted into bytes. It will be bits basically. It will be like in the form of 0 1 1 1 0 something. It will have some uh, thing, right? So this has to be transferred, right? Let's say that we have to transfer a word with whose bit this binary code is 0 1 1 0 0 0 1 1. So in parallel communication, what happens? All these bits are sent at the same time through multiple parallel lines. Okay, fine. So through multiple parallel lines, all the bits are sent at the same time, at the same instant. So here it is a 8-bit data, and it has 8 parallel channels, and it is being sent at the single moment. Whereas in serial communication, what happens? Each like at a single instant, only one bit gets transferred. So of course, you just need only one line for this to get transferred, right? So now if you see advantages and disadvantages, of course, serial communication is slower if you compare it with parallel. But the greatest advantage is like it can be universal. Serial can be universal. You can send 4-bit data also. If you can send 4-bit data also, you can send 8-bit data also, you can send 16-bit data also, right? But in parallel, if you have a connection for only 4-bit data, if there is only 4 lines connected, you can't send 8-bit data, right? So and there have to, like, you have to use so many wires there. So these are the advantages of basically disadvantages of parallel communications. And for obvious reasons, we commonly use serial communication. You cannot see parallel communication being used anywhere now as of now. Okay. So no doubt till now, right? Any doubt regarding this bits? How what is bits? How it is being transmitted? Why?
Sir,
Yes.
we can use 2 bits at a time in the parallel communication so that we get 4 lines, 8 bits.
Sorry.
If we can transfer 2 bit in a line at a time so that
Hmm.
we get 4 lines and 8 bits data
So
transferred at a
that
time.
is not pure parallel communication, right? What is parallel communication? It sends all the bits at the same time. It doesn't have the ability to what to say uh, uh, divide the data into pairs and then send it. So that kind of thing. Matlab, if you have to do such a thing, then you have to add something else. So in a pure parallel communication thing, it is not possible as per the definition, right? So it is a mix up of serial and parallel then.
Okay, sir.
Sir, I have a doubt.
Yes.
Which is better one, serial communication or parallel communication?
Serial communication is better. If you see the trade off between the speed and the what to say cost or easiness, everything, you have to use more wires, like, and it is not universal also. You can't matlab, every time it gets changed. So if you compare all these things, the trade-off, then it is of course serial is better, and that's why I told we commonly use serial everywhere.
Okay.
Okay. So I'm moving to the next slide. So in serial communication, we will study about three famous communication protocols. One is UART, Universal Asynchronous Receiver Transmitter. Second one is Inter-Integrated Circuit. We call it I2C, but it is actually I2C. And then third one is Serial Peripheral Interface, SPI. Okay. So we'll learn about it in detail. UART, it says Universal Asynchronous Receiver Transmitter. So before going into the receiver transmitter part, I'll first talk about asynchronous part. So what is asynchronous communication? In asynchronous communication, the data is not what to say, is not synchronized with any reference basically. Okay, you can just see like you can just see there only one data is getting sent through from receiver to sender. If you see these bottom picture, okay. So here if you want to send one data and then another data and then another data, so how will you know when one data is starting and when it is ending, when another data is because you will not just send the data, you will send some more things also, right? You will send what to say what is this data about, some introduction or some address. Okay, address of matlab, if there are multiple send receivers, if there are multiple receivers, then you will first send the address to which receiver it has to reach. So there will be address, and then data will be there, acknowledgement will be there. Acknowledgement is like to show the data flow has stopped. So all these things will be there. So if you are sending multiple data, then each and every time you have to send a start bit, end bit, start bit, end bit, everything. Okay, so there will be gaps in between. Okay, like it means like to indicate the start and stop of the data, there will be gaps in between. Gaps in the sense there will be a start bus and or like, and between one data and another data, between end and start there will be gaps. Okay, if you are synchronizing it with another set of signal, like there is one signal which will tell you where one data is starting, where one data is ending, or where uh, like where your address is starting, where your address is ending. If all this data is being sent through another signal, a reference signal, and the main data is being transmitted through some other different signal, then it is synchronized. There is a synchronization between these two signals. One is a reference signal, so there is synchronization, of course. So that is called synchronized communication, which we'll talk later. I2C and SPA, these two are synchronized uh, data communication. Okay, so UART is asynchronous. Fine. So now your USB, Universal Serial Bus, USB uses UART. So how it happens? There will be there will be two pins at both receiving and the transmitting end. Those pins are called TX and RX. TX is short form for transmitter. RX is short form for receiver, receiving terminal basically. Okay. So what will happen? from this transmitter, it is written transmitter receiver here, because but it is not not necessary that it has to be transmitter or receiver only. You can have it like this is master and this is slave. Okay, master and slave. So like you will connect TX of master to RX of slave, and RX of master to TX of slave. Okay, so of course if you are transmitting something from master, the slave has to receive it. So transmitting terminal of master has to be connected with receiving terminal of slave. Similarly, if the slave is transmitting something, master has to receive it. So transmitting terminal of slave has to be connected with receiving terminal of master. Fine. So you can see here like the sender's controlling device. Let's say there are two Arduinos, and one Arduino is communicating with another Arduino through wires. So if there is an 8-bit data, then this 8-bit data is sent to the UART, let's say UART controlling unit, UART unit, where this UART unit, like this data is clubbed into a single string kind of thing, single signal, and it is transmitted to the slave. There again at the receiving end, the receiving UART unit, it expands the string into proper 8-bit data, and then it sends it to the receiving controlling device, maybe the receiving Arduino. Fine. So in UART there will be only two wires, TX wire, connecting TX and RX, and RX and TX. Okay. And as you can see here, transmission and transmit and receiving, these two things can happen simultaneously. Okay, but if of course in Arduino you can only execute one statement at a time. Isliye we can't transmit and receive at the same time. But these communication protocols are not constrained only for constrained only with Arduino. This is not just only for Arduinos, right? This communication protocol is protocols are common for every electronic component, electronic systems. So in Arduino, it can only execute one statement at a time. So if it is executing transmission statement, then only transmission will happen. If it is executing only receiving statement, then only receiving will happen. But UART have this capability that transmission and receiving can happen at the same time. Fine. So before we get into this practical task, anyone has any doubt till now?
Sir, what is the difference between asynchronous and synchronous?
Asynchronous and synchronous. Okay, then I'll do one thing. You just wait for some time. Let us finish this practical task once, and then when I go to other protocols, I2C and SPI, there you will actually get to know about the difference of synchronous and asynchronous.
So, what is difference between UART transmitting and UART receiving?
I told this before also. This picture, in this picture, the name nomenclature is given like this, but you can assume like this is master and this is slave.
Okay.
Okay. This is master. This left side one is master, and this right side one is slave. So like anything can transmit and anything can receive. Master can transmit data to slave, and master can receive data also from slave.
Okay.
But as of now, what they are trying to say is this part is transmitting and this part is receiving. But they have given this wrong, and like if this is happening, then this cannot happen. So there is a mistake in this picture, but the thing is like anything can transmit, anything can receive. Yes, but one should be master and one should be.
Seems like one device perform work both type master and slave.
No,
If
how
need.
can it be master and slave at the same time? It cannot be master and slave at the same time.
Okay.
Fine. So if there is no more doubts, then we can move to the practical task. Right. So now we are in this task. We'll try to communicate between two Arduinos, and here you will not only learn about communication protocol UART, but you will learn about other few things also, important things about Arduino. So to save time, I have kept everything ready. Okay. All you have to do is import two Arduinos into workspace. Two Arduinos. Fine. Okay.
Okay.
And then Basically what we do, like here it is already written, like this is RX pin and this is TX pin. Here it is again RX pin and TX pin. But through code we can actually change any pin to RX and TX. Okay, because if we need to do multiple communications, we can change any pins to RX and TX. Okay, and here in Tinkercad, there is some problem with this communication part. Like Tinkercad is not properly able to execute this communication part. So as of now, you take 9 as pin number 9 as RX and pin number 10 as TX. Okay, so as I told you before, RX has to be connected with TX and TX has to be connected with RX. So here 9 is our RX, 10 is our TX, right? So 9 of Arduino 1 is connected with 10 of Arduino 2 and 9 of Arduino 2 is connected with 10 of Arduino 1. Okay, and I told this in yesterday's workshop itself. If you have multiple power sources or if you have multiple systems, then you have to common their ground and you have to short the ground. You have to connect the grounds of both the systems. Then only you can work in a common reference, like your basic reference line. The lowest potential will become common. Okay, so this is the connection part, and then let's come to code. Okay, so in like when you have multiple Arduinos on your workspace, you can change the Arduino here. Like you can follow my cursor, right? Like my cursor is here and I am changing it here. Like here you can change the board, which board you are coding right now. So first we'll check the code of board 1, and to avoid confusion, like it is like the aim is like I should be able to send something from Arduino 1 to Arduino 2. Okay, and similarly Arduino 2 should also be able to send something from Arduino 2 and to Arduino 1. Okay, okay, so I'll start explaining the code. First is this software serial.h. This is an library. This is a library file. This library enables us for making this UART easy. Like we can do UART without this library also. But when we do multiple communications, when we do multiple communication, UART communication, we'll get confused with the nomenclature, with like the board itself get confused, like where to send, what to send. So if we use this library, well, first thing is we can make normal digital pins as RxTX pins, and then you can actually create your own user defined serial ports for communicating. All those in like those details will come when I go into the code, but as of now you just know, like keep this in mind that this software serial is a library, software serial.h. Like these are like same like your C++. How do we include libraries there? Similar header files. Similarly, software serial is a library for easy UART communication. Okay, and we are just defining the pin. This is again a simple C++ command. So a hash define is it's a preprocessor directive which is used to define constants. So RX pin I have T number 10 as RX pin and number 9 as TX pin. Fine. RX pin is 10 and TX pin is 9. I'm just creating a variable so that I can use it in my code, and whenever I need to change the pin, I just have to change here. I can just change my pin number here and my code will get changed accordingly. Otherwise, if I use the pin numbers directly inside, I have to each and every time I have to go and check my pin numbers inside, right? And then character C is for what we'll do is we'll read characters one by one. If a string is being sent, let's say I'm sending hello world, then the communication happens like this. It reads like HELLO. So all these single characters has to be stored first in a buffer space, and then it has to be it will be transferred to the final variable that will be our string data. So C reads each and every bit first basically, and then it sends it to then it totally appends it in rect data. Okay, it joins the whole alphabets into this string. Fine. So then the thing is, we are creating a what do we call? We are creating an object here, my serial. So this is basically a variable name. You can give any name. You can give Mars. You can give Sanjeev. You can give Shubham. Anything. Okay, so this is just a variable name. I'm creating a object, a serial communication, a serial port object, basically called my serial. Okay, so how do I do this? Software, like simple, again, similar to your class objects in your C++. Software serial is the class name. My serial is equal to software serial of Rx pin comma Tx pin, because we have to tell them which pin we are going to use, and the board will accordingly make everything, make it ready. It will make pin number 10 as Rx pin and pin number 9 as Tx pin. Fine. So these are the initial setups, and then we are getting into the void setup function. Okay, so you can give all these things into your void setup also, but again, remember, in void setup we can't use hashtag define, and we can't give a hash include. So all these things are done before your setup function, and then you get into setup. And this also, it is not given inside setup function because we need to use it in our loop function also, right? So it has to be universal. Fine. Otherwise, if you like, that's the reason why we are not setting up inside void setup. So let's go into setup function now. As usual, actually, so for indicating on, like, on which side the communication is happening, to for all those things we are using the inbuilt LED also. We will blink the LED when communication is happening. So aisa kuch, like, it will be of some use in the function, right? So we are using pin number 13 for so that is pin mode 13 output, which means we are going to use the LED light. Okay, then again, pin mode Rx pin input as usual. Like, Rx pin means receiving pin, so receiving pin has to be input, and pin mode of Tx pin has to be output. Tx pin is transmitting pin, so we are outputting something, right? So pin mode of Tx pin comma output. Okay, and then we come into another important part where it is my serial dot begin of 9600. Okay, so my serial, we created this. This is like, this is our object for communication. So our communication is happening to is going to happen through this object, this serial object, my serial. So it is very like obvious by seeing that we are beginning the communication here. That is fine. But what is this 9600? 9600 is your baud rate. We call it baud rate, right? You might have studied this in your 12th standard computer science. If somebody has studied computer science in 12th standard, you might have heard this term in your networking chapter. This is baud rate. So I told you that this communication is asynchronous, right? There is no reference line. There is no reference signal between these two systems. So one system might transmit or communicate in different frequency. Another system might transmit or receive signals, like process signal, in different frequency, right? One frequency might be different, another frequency might be different, right? So sorry, any problem? Okay, so to make these two systems, like, then there will be a problem. Like, if I send two different, like, when I sending, like, this sender's frequency is different and the receiver's frequency is different. So this data will be, when the data is received at the receiving end, it will be of different, like, it cannot process it, basically, right? There is again, the communication is not universal communication. It is like the receiver will not understand what it is. So we need to set these two things has to be happening at a common frequency. Baud rate is nothing but rate of data transfer. Okay, like at which rate the data is getting transferred. So we have to set the baud rate at both the system, both the boards, both the Arduinos. So both the Arduinos should have same baud rate. Okay, so we usually keep 9600. Okay, we usually keep 9600, and there is, like, there can be different baud rates. It can be 11,000 something. I exactly, I don't remember the baud rate. So we commonly use 9600. Okay, It can be 10287. We use 10287. We use 11025. So these are all various baud rates used at this Arduino. Okay, but we commonly use 9600.
So can you explain baud rate? I can understand.
Okay, so baud rate means the definition of baud rate is rate of data transfer. Okay, rate of data transfer, at which rate the data is getting transferred. Now, if your sender is sending at a different rate and the receiver is receiving at a different rate, okay, it's basically speed. Okay, rate of data transfer means it's speed. So if the sender is sending at a different rate and the receiver is receiving at different rate, then there will be mismatch. Okay, the data will not be properly received. There will be mismatch. Okay, so to avoid this, we need to send and receive at the same rate. So what I'll do, I'll set my sending rate and the receiving rate to a common number. That is 9600 here.
So is 9600 is a default number, like you have think like it?
No, yeah, actually there are few default baud rates at which it depends on your it is complex common sense. Like in Arduino there is a system called clock. Okay, this clock is everything. It sets the frequency of your board. Okay, so according to the clock's capacity, there are few constant numbers which we use. So 9600 is very common. Okay, apart from that, there are other things also, like 10287 or 11025. All these things you will learn when you practically do something. But as of now, you can keep this in mind that 9600 is a constant. Okay.
Okay.
So only thing which you have to make sure is whenever you communicate between two things, you should have both the board or both the system should have same baud rate, and that baud rate it should be able to handle. Like that the clock or the system has to be able to handle that kind of baud rate. So if you check that, you will be easily able to communicate. So
Sanjeev, I think someone had a question.
Sir.
Yes.
Yes. Yes, Ashish. Okay, then continue.
Yes.
Sir.
Yes.
Where the serial come from in line 21?
Sorry.
Serial. In the line 21, serial is not predefined, na?
1 minute. I'll come to that point. Like as of now, we are still here only. People had out here. Okay, so if nobody is having further doubt, we'll move further. So next is serial dot begin of 9600. So now this serial starting with capital S, this is something default. This is inbuilt, predefined. Okay, so what is this? This is the serial communication through your USB port. So basically, this will, like, if you connect your USB your Arduino with through USB cable to your laptop, then of course the code I told this in yesterday's lecture itself. The code which is being transmitted to your to your to your board, or sometimes you might need to print outputs on your laptop screen, same like what we do in C++, right? So if you have to uh, uh, send some outputs to the computer screen, so all those communication happens through your USB wire, this port. I think you can follow my cursor, this port. Okay, so that point is by default called as serial, like with S capital. Okay, so that's what. So I told you before, this is why we are using this software serial and all. We need to, because multiple communications are happening, multiple UART communications are happening, because you, like, laptop to Arduino is by default it's UART. We can't do anything. I told you that in USB, UART is the default. UART is used in USB. Okay, so yes. So now this like I think I uh, cleared your doubt. So capital S serial is by default defined inside your laptop, like in your Arduino, as this USB ports UART what to say UART object, communication object.
Sir?
Fine. Yes.
What will be the unit of baud rate?
Unit of baud rate, bits per second. Okay.
Okay, sir.
So now our setup is done. We are set to begin. And again, this 9600. Like in you might be having this doubt. I expected this doubt from you people. Like in Arduino, when we communicate between two Arduinos, we can type 9600 here and in another Arduino also. So that is being set common. But in serial, like in this computer to Arduino wala communication, here we are writing 9600 here. But how will we set this thing to our computer? So that happens when, like in your Arduino IDE. I think I showed the Arduino IDE yesterday. Okay, so there there's an option called serial monitor. Okay, that is the option itself is called serial monitor. If you open that thing, that is the default serial monitor of your Arduino board. So whenever you have to print something, you will be printing it there. If you have to print and see some output, okay, then you will be printing it there on that serial monitor. So when you open the serial monitor, there will be a tab for that where we set up the baud rate. So we can select the baud rate there. So if you are using 9006 serial dot begin of 9600, then that serial in that serial monitor you have to set up that the data is being received or sent at the baud rate 9600. Okay. So now let's get into loop function. So first thing is we are having this if condition. If my serial you know, right, my serial is. So first what we are doing is we are going to receive data. Like this function is for receiving data. This one section is for receiving data. Okay, first we are checking whether there is something available for receiving. Okay, if is there anything at my doorstep to be received. So if my serial dot available of, so this available of function will return 1 if return some positive value, basically, like whenever there is something at your receiving terminal. Okay, so my serial is, you remember my serial is the user defined serial port. So if my serial dot available of is greater than 0, okay, so we are initiating this string data with an empty string. Okay, simple C++ concept. And then while loop again. Yesterday somebody was asking, can I have another loop within the loop function? So here it is. If while my serial dot available of, till I have something at my receiving end, I'm reading it by character. My serial dot read off. This read off will read by character. My serial dot read off will return the character to C. C is a character constant character variable we have defined before, and this thing is getting appended in rec data. Okay, so I am reading by character and I'm adding it at the end of rec data every time. Okay, so simple. My data, anything if I am having at the receiving end, it is getting received and stored at rec data. Okay, now this is capital S serial, which means the inbuilt, the predefined serial, which is our laptop monitor. Okay, so this here I'm just printing that data received. Okay, so data received is equal to plus whatever data we have received, we are printing. Okay, so serial dot println of println is print is println is we'll print line by line. So whenever you use println, it automatically goes to the like after printing it automatically goes to next line. If you don't use ln, it will stay. Matlab, same like your C out, C in C out. Like you use endl, right? So endl, if you use endl, it automatically goes to the next line. So similarly, so print ln is for printing something on the screen and go and the cursor goes to the next line automatically at the end of the string. So we are using serial dot println of the data received equal to plus the actual data received. So here we are printing the data on the monitor, which means if a data is coming to Arduino, it is receiving it and it is printing it on the screen. So this section is done. Okay, now the next section.
What is use of rec data in this loop? Sorry, in this statement.
How will you like, let's say if I just have to print it on the screen, if I just have to print it on the screen, I can just print it here, print it character by character also, receive it character by character and print it character by character.
Yes, sir.
But the thing is, if I have to use my data somewhere else, like usually what will be the purpose? Like if I'll receive some sensor values and I have to use it for some other calculation sometime. So if I have to use it for some other purpose, then I need to have it as a single variable, like into single variable, right?
Yes, sir.
Okay.
Okay.
Yes. So now the transmission part. Now the receiving part is done. Now we'll talk about the transmission part.
And sir, what is it print on the monitor screen? Serial dot print ln s
Yes.
is equals to plus or reg data.
So here
Means
you can
plus.
see, I like C++. Have you studied C++ before?
Yes, sir.
Yes, right.
Yes.
So whatever, like first of all, it is given in double quotes, which means it is a string. So it will automatically get print on the screen.
Sir. Yes, sir.
And then along with that, it is getting appended with the data stored in this rec data. So what? So if I send hello data, this rec data will have hello data. Sorry, hello world. If I send hello world, this rec data will have hello world inside this. It is hello world is stored inside rec data. So now on screen it is printed that data received equal to hello world.
Okay, sir. Or when loop is begin, then plus reg data is performed with that.
Sorry, when loop begins.
Actually, it's basically concatenation of string before printing, right? Because rec data is predefined as string, right?
Yes, sir.
And their data received, it's also a string because it's inside double quotes. So before printing, it is actually concatenation of two strings, and then it is being printed. It's not
Okay,
like
sir.
if you
Get
write
line.
two integers there and add them,
Get
so
line, sir.
they will not be printed. Yeah.
Okay, sir.
So we'll move to the next part. Like the next part is I said the transmission part. So how this transmission is happening? We need to enter something in our screen, on our computer screen, and that has to be read by the the Arduino IDE. Send it to Arduino, and then that has to be sent to the other Arduino, right? So first we need to check whether there is something entered on my serial monitor. Okay, so now I am checking the serial of the predefined serial, the capital S serial, right? Uh, uh, so previously here, like it is very same. Previously we were checking whether I have something at my receiving end of the UART. So there we were using my serial of, because we defined it as my serial. Here we need to check our serial monitor if some string is being entered by the user. So serial dot available of, if something is available, then it is like, then again same thing, we are creating an empty string. We are initiating the reg data. The reg data is already created. We are initiating it with this empty string, because what if we have used this reg data before? Matlab it goes in loop again and again and again. So reg data might be having some other data from previous execution. So we are just emptying it again. So empty string, we are initiating it with empty string. And then again we are using serial dot read string. Now we don't get confused about these things, because there are few problems with, like, when we use serial dot read string of everything. Okay, so to matlab, this is how when we read Arduino, from when we receive uh, data, we usually don't use read string of. In C++ also we never use matlab, string functions have some problems, like maybe have to be careful while using that, right? So similarly, so here we are just using serial dot read string of. We are just directly reading it as string and storing it in rec data. Okay, and then we are using we are printing it on the screen once, just to confirm. So if you just enter hello world on the screen, it will print back transmitting hello world. Okay, and then it is sending it to the serial also. My serial dot print of rec data. Same command. My serial dot print of rec data. Okay, so any doubt till here? If I have to receive something, I have to receive, like, the aim of the code is to receive something from the serial monitor and send it to the second Arduino. So first
Is the data is I mean outputting for one at a shot, or there is a loop continuing for H, then for E for hello
no
world,
no no
like?
no there is no loop here. Like you can see that there is no, like, it is read as a single. That is the advantage of serial communication, right? Here also, see, here also, this loop is not for the communication between two Arduinos. This loop is for reading from from the RX pin. Like at the end of it's like someone is waiting at your door. Okay, so from that RX pin, we are reading it one by one. Okay, but the communication from, you can see here, the transmission has happened as a single string. Okay, and it has come as a single string because it's serial communication at the like, but when we read it at the from the RX pin. Okay, so that
In
we
the
are doing
while
it
loop,
by character.
I'm talking that in the while loop, the data for the hello world, the data is reading at a shot, or for H there is a loop, or the second time there is another loop. This is how the system is reading the hello world.
No. See, once you get into, like, this is basic C++ flow, right? Get into void loop. It is first checking whether there is something is available at my RX pin. If it is available, then yes, it is getting into this
Variable.
condition block, and then it is initiating with an empty string, and then a separate while loop is starting. Until and unless this while loop is completing, it will not go to this part, right? So till I have something at my RX pin, while my serial dot available off, till I have something at my RX pin, this while loop will go again and again and again. First H will be read, and then first C is equal to H, and then rec data is equal to H. Then C is equal to E. Now rec data is equal to HE. Then again C is equal to L. Rec data is equal to HEL. Like that it goes, and when it is equal to hello, and the null, what do you call, null variable, right? And till you receive that part, and then only this while loop gets over, because then only your my serial dot available will become 0, and then it comes to the rest of the code. Okay.
Sir,
Hmm.
sir, how receiving can take place before the transmission?
See, the code, like, it is
As
just checking, like it can be ulta also. Okay, and frankly speaking, I'm using this code because in Tinkercad only this code is working for UART communication, because like there are few problems with simulating the communication part. Okay, so if I make any change here, it is affecting the communication. So इसलिए I'm maintaining this code. When you try, you might not be getting it in Tinkercad, but when you try it on the actual Arduino board, the process is very simple. You can, like, it, you can easily understand. Okay. So it is just like first it is checking if I have something at the receiving end. If there is something available at the receiving end, it will receive. If not, it is checking whether there is something to transmit. Okay. If there is something to transmit, it will transmit. Okay.
okay, yes, sir.
Okay. So now the same code is uploaded in the Arduino 2 also, because same function. If there is if something is available at the receiving end, then read it, print it on the screen. If there is something available on the screen, read it and send it to the other Arduino. Okay, so the function is same, so the code is also same, and the last part is just for like just a delay. Once a communication is over, once if it is printed, it is giving some gap for us to actually see the screen what has happened, because otherwise it will go very fast, because Arduino's processing is very fast. You cannot read anything properly on the screen. So if you have to read properly on the screen, then you need to give some delay. Then only you can read. So this 2-second delay is there, and with LED blinking. Okay. So this LED blinking will indicate that one set of communication has finished. Okay. So these are few basic things. Now we will see what is happening. I'll click on start simulation. So the simulation is has started. Now I'll open. Now you see I am on Arduino 2. Okay, my like now I am in Arduino 2. I have selected Arduino 2 here. To Arduino, R3. So I am on Arduino 2. So if I open my serial monitor and I'm writing HELLO hello world, and I'm clicking on send. Okay. So now it is telling transmitting hello world. So hello world is being transmitted from Arduino 2. Now I have to go and check Arduino 1. My Arduino 1 should also have it should say SS received hello world. Okay, let me check. Yes, it is same. Okay, and now I'll try sending it from here. You just check it once. My Arduino 2's serial monitor is just having transmitting hello world now. Now I'll go and check Arduino 1. I'll type again what Mars. Okay, MARS. I am sending it. Transmitting Mars. Let me go and check there in Arduino 2. SS data received is equal to Mars. Fine. Okay, so I'll upload this code in the PPT, and I'll upload the PPT in Drive, and I'll share the link in the Facebook page also and the Linktree profile also. You can go through this. Fine. You might face some problems when you simulate in your uh, uh, Tinkercad. So I'll make a copy of this Tinkercad also, and I'll upload it too in your in the Linktree, so that you can try this. Fine.
Yes, sir.
Any doubt till now?
Sir, I have doubt. When
Yeah.
serial communication used when data send it to Arduino board by the computer, and my
Serial
serial
monitor.
used
Yes,
when
serial
sensor
monitor
is
is
used.
like, it's like your in your C++ you have this output screen, black color screen. Similarly, here we have
This is
serial
serial.
monitor.
Or when we use by sensor, then it is my
No,
serial.
I named it my serial. I created a serial a communication object, an UART object, and I named it my serial. See, I have created software serial,
Okay, serial
my
is
serial.
already present in the software serial
Yes, it
library.
is defined, it is
Okay,
predefined. So here I
okay,
am
sir.
creating another way. I can name it anything. Okay, I can name it
Okay,
Mars
sir.
also. Okay.
Okay, sir.
So now let's go to,
Sanjeev, I'd like to add one more thing.
yes, sir.
Can you go back to the Tinkercad? Yeah, so actually, as Sanjeev has told that the serial communication in the line 21 here, serial dot begin 9600. So this capital S serial, it is the communication through this USB port of Arduino. It is the communication between Arduino and the laptop it is being powered through. Okay, so it uses by default 0 and 1 pin. So that is the main reason that we do not use 0 and 1 pins in our code anywhere, because it might affect communication between Arduino and the laptop.
Okay, sir.
And this is the case with Uno. When you use Mega, there are multiple RxTX pins. And apart from that, you can make any digital pin as RxTX pin using that software serial.h. Okay, so in Mega, there are multiple RxTX pins. Okay, you can see it here. Fine. So let's go to the next thing, that is I2C. Now I2C is synchronous. Just wait for some time. Yes. So now I2C is synchronous. What is synchronous communication? I told you before that there will be a reference line also. Okay. There is a reference signal sent separately, and these two signals are in synchronous. Like these two signals are synchronized. Okay. So there are two signals now. One is serial data. SDA is for serial data, and another one is serial clock. SCL is serial clock. Now this clock line is your reference line. Okay, so this clock line will have at every at every instant it will go high down, high down, high down. Okay, so it is a reference line, like it always goes high down, high down, high low, high low, high low, high low. Okay, and this SDA is our actual data transmission, which happens like, oh, this SDA same signal which was sent here in TX and RX, whatever was sent. Okay, whatever data was sent, same thing, same signal only, but now along with that signal, that data signal, we are sending one more signal which is a reference signal, which will always go high low, high low, high low. Okay, which means if you compare with this, it is 1 1 1 1 1 0 1 1, right? There it is 1 0 1 0 1 0 1 0. It will go in that. It is universal and it is common, like it is very it is universal thing. Serial clock is like that only. So it is a reference line now. So now what is the advantage? Now the thing is, we'll know that when the code is starting, like whenever like the code, the start is initiated by like initially SCL and SDA both will be maintained at high. Okay, both will be maintained at high, ACL and SDA. Sorry. So ACL and SDA are maintained at high. So at the instant when SDA goes low, whenever the SDA goes low for the first time, it is considered as the start, but ACL remains to be high. Okay. So before the start of communication, SCL and SDA are maintained high, are maintained at high potential, SCL and SDA. Now, whenever whenever you have to initiate whenever you have to start a communication, start I2C communication, your master makes SDA low. Okay, your master makes SDA low. I told you master controls the transmission. So whenever this SDA is becoming low, then it indicates the start of the communication. So now from that moment, they'll start checking the what to say, we'll start checking the reference line, the clock line. So from that moment, first 7 bytes of 7 bits, sorry, extremely sorry, I'm just getting confused every time. First 7 bits is address line. Okay, so we'll check the clock as a reference. So first 7 bits are for first 7 highs. Okay, these are for, so first 7 bit is for address, and then 8th bit is for read or write, because you can see it here. Previously we were having transmission line and receiving line, right? TX line and RX line. So it means at TX point you will always transmit, and at RX point you will always receive. Now it is not like that. Now we just have SDA, only one pin called SDA, right? So now this SDA pin, through at this SDA pin we can receive data also, and we can send data also. Master can receive data from slave, or master can send data to slave. Okay, so anything can happen. So now master will say whether I am going to read or write. Okay, read means I'm going to receive data from slave. I am reading some data from slave, which means I'm receiving data from slave. Write means I'm going to send some data to slave. I'll be writing something, I'll be sending some data to slave. Okay, and address, what is address? See, you can see there can be multiple slaves, I told you. So which slave I have to communicate? Okay, and only one with only there are only one SDA pin and one SCL pin. Okay, so now which slave I have to communicate? So for which I have to send a separate set of bits called address bit. In you can see here in UART, we have to, if we have to transmit to multiple slaves, then there has to be multiple TXRX. Okay, you can see that's why in Arduino Mega we have multiple TXRX. There are so many TXRX here, right? Because with one set of TXRX pin, we can't communicate with multiple slaves. As Dhruv sir said, like when Arduino is communicating with laptop, if we use the same pin, we cannot, like, the communication gets collapsed. So, but in I2C, the advantages your sender and receiver can have only one set of SDA ACL pin. Okay, and with that itself, we can communicate with multiple slaves, right? So for which we need to send a separate set of bit at the start called address bit, and then read or write, and then acknowledgement bit. This acknowledgement bit is set by the slaves, like what should be the acknowledgement bit, and then we will send the data acknowledgement. So you can see all this data is sent as a single signal without any gap in between. Okay, just because it has one reference line signal, reference signal called SCL. Okay, so this is the actual data line, and this is the reference. So first 7 bits is for address, 8th bit is for read or write, 9th bit is acknowledgement. So how will we know, or which is 7th bit, which is 8th bit? That is being found with the help of SCL, serial clock. So this clock is the reference line, and there is a synchronization, and that's why it is called synchronized communication. In asynchronous communication, there is no clock line or reference line. So I think it is clear now, right? Fine. I guess it is fine. So now let's go to the last communication protocol for today, which is SPI, Serial Peripheral Interface. Okay, so now it is almost similar to I2C, but it is kind of combination of I2C and UART. Here what we have separate line for transmission from master to slave, and separate line for receiving from master to slave. Okay, so here the advantages, there is no need of address. Okay, we don't have to provide address. So here similarly we have the first pin is called MOSI. MOSI is master out, slave in. Okay, so here you can see master is producing, and master is transmitting, and slave is receiving. Master out, slave in, and where it is getting received, master out, slave in, pin of the other pin, the slave part. MISO is master in, slave out. Okay, so from slave, master is receiving, master in, slave out. Okay, So there is 2 pins instead. Like previously there was only one data pin called SDA, serial data. Now we have 2 data pins. One is MOSI and MISO. Okay, and this is again serial clock. SCLK is serial clock, the clock signal which we studied in I2C. Okay. Now this SS pin is serial select. Sorry, slave select. SS is slave select. I told you there is no address in SPA. We don't have to provide address because here we have to send a separate signal to select which slave we are going to communicate with. So there are multiple save select pins in master, and there is only one slave select pin and slaves. So to whichever slave I'm going to communicate, I'll send a signal. Maybe I'll make it high low. I'll send one signal that I'm going to communicate to you. So only that slave will read the data coming through this MOSI and MISO, because you can see only the same line is being connected with all the slaves, right? One pin, one green line is being connected with 3 slaves. Now which slave, matlab how the slaves will know which data is for me, which data is for slave 1, which data is for slave 3? It is through this wire called save select. So this again in like the disadvantages, the master has to have so many number of slave select pins, and if it is having only 3 pins, it can communicate only with 3 pins, 3 slaves. It cannot cross that limit. Okay. So it is similar to I2C. To brief up, I'll tell again, it is similar to I2C, but now there are 2 separate data lines, MOSI and MISO, and there are separate slave select pins to select the slaves instead of providing an address in the data line. So any doubt till here? Any doubt? Any doubt? So it's totally clear.
Sir, the graph of the slave select is not having any reading valid. So,
Sorry, you're not clear. Sorry.
sir, the first graph, the SS hash slave select.
Yes. Yeah, I told you, right? Like why there has to be any need of high low, like multiple high low. Like it has to just tell you I'm going to send a signal to you. So it will just make one high and low. Like if you see, it was maintained at high before. Okay, it was maintained at high before. It was high before. When the communication is starting, it is becoming low. So it means whichever slave is getting low, that only that slave will be able to read. So till the communication ends, it is maintained at low. And when the communication stops, it again moves back to high. So in that range of it being low, the slave select pin being low, the communication happens. And whenever it is stopped, whenever the slave select pin becomes high, that slave stops receiving data or sending data. Fine.
Yes.
Okay. Anything else?